Okay. Well, so I also have a couple of project updates from Docling to give as well. Firstly, making Docling agentic. Docling now has an available MCP server that you can deploy on several different platforms. Most simply, you can do it in LM Studio. There's a single-click install. This means that you have an MCP server that has access to all of the basic Docling functions, right, as tools. So you can do document conversion, manipulation, including like chunking, for example, or content creation using those MCP servers. You can actually also find Docling in Claude, specifically within the Claude, I think it's the marketplace or the tool marketplace. I'm not sure exactly what it's called, but if you go and look up Docling, you can find the Docling MCP. You just need to deploy your own Docling serve instance on your local machine or wherever you're deploying it, and you can connect that directly to your Claude. A couple of other updates that are interesting, schema-based data extraction as well. So we talked about, extracting full-page documents. We talked about extracting full document corpuses, but actually just extracting key values essentially is what we're targeting with schema-based data extraction. So you can actually predefine some pedantic schema. So if you had a lot of invoices that followed a very similar schema, you can take that schema, predefine it, and Docling will be able to extract the key values that you defined within that schema as well. Very simple, couple lines of code there. A couple of other recent interesting highlights. Docling is also available in Java as well. That was actually an external contribution to the Docling Java project. And I think if you just look up Docling Java on GitHub, that is also somewhere there. We also have been working closely with NVIDIA. I mentioned within the conversion pipeline, the document conversion pipeline, there's all those models that are used, the OCR, layout analysis, table former. We're actually working closely with NVIDIA to try to get those accelerated for NVIDIA hardware. So right now there are GPU accelerations already available, but further optimizations from the NVIDIA team are always appreciated. Somewhat recently, Docling now also ingests LaTeX as a format. So previously we already could output into LaTeX, but now we can also ingest LaTeX. That was also an external contribution. And then there's also a new model from IBM. It's called the chart to CSV model. We talked about during the presentation how you can iterate through the converted document or the Docling document to target only specific images within the document. The chart to CSV model is actually a visual language model out of IBM that takes charts and converts them directly into CSV, which makes a lot of sense. But with Docling, it integrates really well because now you can just iterate through your full document of charts and export CSV from those charts instead of keeping them in image format. Okay, more exciting, and this is not this is not necessarily a recent development, but this is more of a interesting extra bit that Docling provides. So evaluation is something that's particularly difficult with document conversion, right, or information extraction, because actually determining like a score or a ground truth isn't always the easiest thing to do. And we can see on this slide here, like in the top left, both of them are segmentations of the exact same document, right? But one of them is bounding boxing the text very tightly, while the other one has some overlaps, but is bounding boxing the paragraphs in a specific way, right? Technically speaking, both of them are accurate. It's very difficult to say, unless you have a very specific use case, that one is more accurate than the other. And so using traditional evaluation metrics for determining the quality of an extraction isn't necessarily trivial, right? There's not a ground truth that necessarily applies to everyone's documents. And so the Docling eval library or project, you can also find it's also open source on GitHub. What it does is it pulls several of the most popular open source evaluation frameworks and evaluation data sets for document evaluation specifically, and it allows you to compare the Docling extraction, reading order, bounding boxing, tagging, all of that stuff. It allows you to compare that with some of the popular open source data sets, right? And it actually helps you visualize the differences between what the Docling export is versus what the data sets are expecting, right? And so this allows you to see, like here, which data set is most applicable to the data that I have, which data set actually fits the use case that I have the most, right? Which reading order, which data set has the reading order that is most accurate to what I'm doing, and gives you a better idea of how you can evaluate Docling's output versus what is traditionally accepted as ground truth output. Because again, the ground truth varies a lot on various different data sets, right? Okay, The other piece that is a work in progress and also very interesting development is the push for an ISO standard through the LFAI and Data Foundation. So one thing we talked about during the earlier presentation was that Docling and what is needed today is taking information from human readable or human acceptable formats to machine readable formats, right? But when we look at some of the machine readable formats, Markdown is not very metadata rich. You lose a lot of information going to Markdown, but something like HTML, which a lot of models are trained on, while it's technically machine readable, it wasn't created with AI in mind, right? It wasn't created with the idea of tokenization in mind. And so if you look at the actual HTML representation of any given structure, it's very verbose. You know, like the concept of tokenization, the concept of compute costs and saving tokens wasn't really a thing when HTML was created, and so it's not as condensed as it could be. Doc tags, and I mentioned that doc tags has actually a direct tie to the Docling document format. You can actually change between Docling document and doc tags very easily. But doc tags is an OTSL-based format that can represent the exact same structures as HTML while using around 40% less tokens, right? And so this is a ISO standard that we're hoping to push through so that more models are trained using doc tags, more models are capable of inferencing across doc tags. Because in the long run, if you are saving tokens in data representation, if you're saving tokens in representations of outputs, then you are also saving a ton of compute power in the training of the models and the inferencing of these models, et cetera. There's also some community adoption numbers. This is actually slightly out of date. There is now over 50,000 GitHub stars and a little bit more active contributors, but always feel free to check out Docling. We love outside contributions. If there's a specific use case or a specific output format that you're particularly interested in, you can always contribute it back to the project as well. Also, the growing number of ecosystem integrations. There's a lot of different AI projects now that we're connected with, LlamaIndex, LangChain, Haystack. Red Hat also ships Docling within its RHEL AI 1.3. It's an officially maintained package there. IBM also recently released a supported or hosted Docling as a service, but all of this is still based on the open source Docling project, and a lot of these integrations are still regularly maintained, either by the community or by the internal Docling team. If there's anywhere you'd like to see Docling, always put in a PR or an issue or build out the integration yourself. Okay, that is it. I have the slide again in case you are interested in checking out the various platforms that Docling's on. Thank you.